Here, and today we're going to be taking a look at some actual overclocking for once, though it's not particularly hardcore, as the cooling system I was using was just a 280mm AIO, which I would consider an extremely normie cooling system. But regardless of how normie the cooling is, I managed to get a top 10 Ycruncher-Pi 12 CPU core score. With the Ryzen 9 7900X, and here's the score on hardware bot. It's 16 seconds, 896 milliseconds. And if we go to the actual rankings, you can see that basically the only things that are faster than my 7900X are other 7900Xs, but on liquid nitrogen, and the Intel Xeon W5 2455X. Also on liquid nitrogen, and that includes this one that was running at 4.6 gigahertz. Apparently those CPUs are like weird with like the memory controller gets weird about low temperatures. So that's a real balancing act to run, like, to max these CPUs out for Ycruncher, because Ycruncher is an incredibly heavy multi-core benchmark, but it's also incredibly memory bandwidth heavy. So you need like both high CPU clocks and a lot of memory bandwidth. And actually on some CPUs it'll be more memory bandwidth than CPU clock. It kind of depends on the ratio of cores to memory channels and memory speed, but like, yeah, this is kind of an everything benchmark, at least on the CPU side of things. So I like it because it's not like Cinebench, where Cinebench only cares about one thing, and that's your core frequency, maybe your ring clock. But anyway, so yeah, Ycruncher is a very, very, very heavy benchmark that also has more than one aspect to it, which I like. And it also makes, like, in terms of like CPU load, it makes Cinebench look like an absolute joke. Like in terms of the temperatures and peak power consumption, Ycruncher is insanely heavy. This is basically as close to a like full-blown stress test as you're gonna get with benchmarking on hardware bot. Though again, it depends kind of how memory bottlenecked your CPU is. If you have a CPU with very slow memory and a lot of cores, then it's actually not that hot because it ends up being really bandwidth starved. But anyway, so that's what Ycruncher is, and yeah, I have a rather high score considering how normal a cooling system I'm using. And because it's so memory heavy, you can see that, like, I'm not really running a particularly high CPU frequency, but yeah, I'm competing with chips running, like, I'm approaching the scores of CPUs running like 6 gigahertz and up, and I am comfortably beating scores that are running 5.6, 5.8, 5.7, 5. Now, actually, this one's on PBO, so the load frequency won't be anywhere near 5.9, but you sort of get the idea. Yeah, so like the score for me, the score is very much carried by the memory settings. Also, the frequency readout over here is actually a bit off because if you look at the screenshot, you'll see that CPU-Z is reading out 104 megahertz on the 101.4 megahertz on the BCLK, whereas Benchmate is reading out 102 megahertz, and that's just a software reading error. It's like a thing with Ryzen that's kind of annoying. I don't know if there's any fix for it. Actually, you can see CPU-Z making the same mistake for the DRAM frequency for some reason. I have no idea why. It just, like, that just happens. But, yeah, anyway, so that's the score. Now let's take a look at the setup for it. So the system specs are, of course, a Ryzen 9 7900X, which was provided by AMD, so big thank you to them for the CPU. The motherboard is a Gigabyte B560E Aorus Tachyon, provided by Gigabyte, so big thank you to them for the board. And the memory kit I used is the V-Color Manta X Prism RGB DDR5 8000 CL38 kit, which that's the XMP spec for it. It's meant for Intel CPUs, but I think I've mentioned in the previous video with this kit how well it works for me with Intel CPUs. So yeah, anyway, that's the system specs. Now let's take a look at, like, actually running the benchmark. So I have a slightly detuned version of the settings that I ran for my actual, like, top score. And when I say detuned, this actually, if we get lucky on a run, it might actually outscore my top score on hardware bot by like 6 milliseconds. Like, I've seen that earlier. While trying to record this video, it's managed a 16.893, whereas my posted score is a 16.896. But 3 milliseconds, I actually don't care. I'm not gonna make a whole new screenshot just for 3 milliseconds. Anyway, so if you're going to be running Ycruncher for hardware bot, what you're going to want to know about this benchmark is that the Benchmate priority settings over here, these don't work. These just adjust the priority of the sort of UI, like the wrapper. They don't adjust the priority of the benchmark itself. So if I close Ycruncher and I set the priority to real time, right, and we open it up, and then I'm going to pull up Task Manager. And in details, you can see we have the process priority over here. I'm just going to rank all of my processes by CPU usage. And if we, can we even find the wrapper? Well, okay, we can't, but I'm going to press run on this. What you're going to see is that we have this process over here that's like 90, that's Ycruncher. That's the actual Ycruncher process, which is hitting like 95% CPU usage, and it's below normal, which is not ideal because we want Ycruncher to run fast. Also, we are, like, I did say the settings are detuned, but that doesn't mean they're not on the edge. So that just crashed, which that's fine. We're just going to set that back to below normal. We're going to open up Ycruncher again, and there's a way to work around that whole below normal thing. And the workaround is that you create a batch file, and there's actually multiple workarounds. Like if you don't run Ycruncher through Benchmate, you can tell Ycruncher to, because what basically happens with Ycruncher when it spawns the like actual workload, it sets its own priority below normal, because if you set it to like normal or high or real time, it can cause the system to go completely unresponsive. So to avoid that, Ycruncher sets itself below normal, which also means you can't use something like process lasso to set it to real time. I tried that. That doesn't work. But you can run Ycruncher without Benchmate in real-time priority. There's a way to do that. We're not going to go over that because that's not what I used for my score. What I used for my score is a batch file with this in it. And basically, you just have to run this as administrator. Like, you just have to run this batch file as administrator after pressing the run button on Ycruncher. Actually, I'm going to pull up Task Manager again so you can see it in action. And I run it as administrator through a shortcut, and that shortcut is to just set as run as administrator, right? So anyway, we're going to close all of that. And now we are still ranked by CPU usage, so we hit run. You can see it's below normal. I run the batch file, and now it's real time. Also, the mouse is lagging, which is why it normally runs below normal. And apparently, the room heated up enough that the CPU now won't run Ycruncher at all. So that's actually sort of the main the main limiting factor with this setup is the cooling system by a very large margin. I literally cannot raise the core voltage much at all because, and actually, well, we'll try if we get lucky to actually get a pass. But yeah, like I closed the door and now the room is a couple degrees warmer, and so it won't run anymore. Ryzen 7000 is extremely temperature sensitive, so you really do have to be careful that you don't, like, as you're trying to max out your CPU frequency, you don't accidentally use way too much voltage. If you're not sure, I would basically start with like 1.2 volts and work up from 1.2 volts, which sounds absurdly low, but if you start at like 1.35, that's already too high on most on most motherboards and most cooling systems, 1.35 is going to be way too high, even if you're on a single CCD CPU. So anyway, but we'll see if I get lucky and actually get it to pass. We'll try. If we don't, then I'll just lower the BCLK until it does. But I do actually want to show the thing going off, so we're going to go run. And yeah, you can now see that it's running in real time. Please don't crash. There, so we got a 1693, which is actually very close to the score that I posted on HardwareBot. So, yeah, and that's really all that went into this score on my end. Was just that batch file and nothing else. In fact, the operating system that I'm using for this is actually terrible. You might recognize this operating, like if you watch a lot of my videos, you might recognize this operating system from the wallpaper and also all of the icons on the desktop. Like, yeah, I should probably reinstall this OS at some point, but I don't feel like doing that. Anyway, let's go into the BIOS and take a look at the actual settings that I'm using here. So, here we are in the BIOS. It's all squished, probably because I have CSM turned on. Yes, I do have CSM turned on, so that's why the resolution's all weird. Anyway, I have the BCLK at 101.65 right now. I think for the actual score, what I ran was 101.4 with, I think just the the good CCD at 5350. And they're like, yeah, the second CCD on my CPU actually sucks. And that's normal. If you have any dual CCD CPU, the second CCD is always going to be significantly worse than the primary. But I also think that my 17900X might not be that great in general, just judging by some of the other scores that are on the Ycruncher ranking. Because yeah, I like my second CCD is truly awful. Like if I try to run this chip with like if I run the if I run the CCDs at the same frequency, like I'm down at like 5.3-ish. Actually, it might be below 5.3. Yeah, it's like 5.2. Um, so yeah, the second CCD on my chip is really, really bad. And primary seems okay, but I'm not like I have a sample size of 1, so I'm not sure on that. Anyway, yeah, so that's the CPU settings. Though also this 101.65 configuration actually scores very similarly to ultimately what I posted. So we're just going to go back to that right now. You can see that I have the XMP profile enabled. This probably isn't necessary, but with Gigabyte motherboards, not turning on XMP on sometimes causes issues. Sometimes it doesn't, but there's no hard like Gigabyte boards don't really do anything. Well, it's mainly about the voltage controls. If you don't turn on XMP, you sometimes won't get like proper access to voltage controls for the memory. Anyway, the memory ratio, like yeah, the memory ratio is at 80. So we're getting over DDR5 8000. We're getting what 80 times 101.65, which will be like 8100-ish. Yeah, it should be like actually it should be like 8120 if I'm not mistaken. Something, yeah, because you'd have 80 plus 80 plus 40. So it's like over 8120 on the memory. The Infinity Fabric's at 2133 because I am just using straight BCLK over here. This isn't ECLK overclocking, so the Infinity Fabric is also getting overclocked by the BCLK. And the thing is, if I set it to 2166, it doesn't actually cause outright crashing, but it slows Ycruncher down because it starts hammering the error correction on the Infinity Fabric. And there's nothing I can really do about that with the CPU. I tried lower SoC voltage, fiddling with the VDDGs, and yeah, it doesn't ever clear up. So 2133 is sort of, well, 2133 isn't the max Infinity Fabric. The issue is if I bump the Infinity Fabric ratio to 2160 with the BCLK that I'm running, it ends up at like 2190-ish, and that's way too high. This CPU probably maxes out at like 2170 on the Infinity Fabric, if even that. It might be like 2160-ish. Yeah, so Infinity Fabric's at 2133. The memory controller is obviously running at half the memory clock because that's the only way you're doing DDR5 8000. And DDR5 8000 is actually beneficial to Ycruncher quite significantly. That's like a big part of why my score is so good, is because Ycruncher is crazy memory bandwidth limited. And so this is one of the benchmarks that sees the biggest benefits from the new AGSA's ability to run very high memory speeds in the 2-to-1 mode. So, yeah. Anyway, for CPU settings, I have the core voltage at 1.295 right now, but yeah, like it's borderline, and I really can't go any higher on it. Like I tried up to like 1.35 volts, and that just makes the stability significantly worse. Because with like the funny thing with Ryzen is technically the thermal cutoff for static overclocking is 115 degrees Celsius. Your CPU, if you're pushing high frequencies, the CPU will get completely unstable long before you get anywhere near the 115 degrees Celsius thermal cutoff point. So, like, if we go back to the score that I posted to HardwareBot, you'll see that, like, Benchmate is reading out that the max temperature was, like, 92 degrees Celsius, which is way below the thermal cutoff, right? Like, that's, what, like, 23 degrees below the thermal cutoff? Yeah, if the temperature goes any higher, it just crashes. So, um, that's like, yeah, so that's sort of what's going on with the core voltage here, is just like that's literally, and actually depending on how warm the room is, like it might run a little bit better if I lower the lower the voltage rather than raise it. But today's been relatively cool compared to the day that I actually made that score, so I have the voltage relatively high. But yeah, I had no success with getting higher speeds to work with like more than 1.3 volts. So anyway, and since we're on the topic of core voltage, let's take a look at the LLC that I'm running, which is standard. Because that's the least amount of V-droop that you can have on, I mean, not the least, that's the most V-droop that you can have on the B650E Tachyon, which I'd still say is not enough V-droop. Because I have measured this motherboard with the oscilloscope, and even on standard LLC, like every other 8GB motherboard that I've measured, there is very noticeable undershoot. It's better than all the other Gigabyte motherboards because the voltage regulator on this board is actually somewhat better designed. Also, it has 10 PCB layers, which is probably helping a bit. But yeah, it's still like there could be more. If there was an option for more V-droop, I would use the option with more V-droop. Unfortunately, standard is as much V-droop as I can get on this board. So yeah, there's actually a small possibility that if there was like a droopier LLC, I could actually run slightly higher frequencies for Ycruncher, because Ycruncher is a very transient workload. Like Ycruncher really is like in many, like, peak benchmark in my opinion in terms of like how much it stresses out. Like, it doesn't have a very high sustained power draw, so it's not like much of a thermal test. But from like a transient loading perspective, from the memory load, from how hard it is on stability, it's a really neat benchmark, because compared to something like Cinebench, it's really difficult. But yeah, so I'm on standard LLC, and if I could have more V-droop, I would have more V-droop, but I can't. So SoC, I have it at high load line calibration, because the SoC actually doesn't really do, like, the SoC doesn't see massive transients, so we don't need a lot of V-droop there to have good voltage regulation. So that's what's going on with the core voltage. Like, using using a more aggressive load line calibration would actually just make the stability worse. Because the CPU would run hotter and the undershoot would just get worse. So, yeah. That's again why if I could have more V-droop, I would have more V-droop. Anyway, so that's the core voltage setting. The SoC voltage is at 1.15 volts. Because in 2-to-1 mode, the memory controller is clocked so low that you actually don't need a lot of SoC voltage, even when your memory frequency is at like 4 gigahertz, right? Because the actual data rate is at 8,000 megabits per second. Anyway, for the memory voltages, I have VDDIO mem at 1.4 volts, which that's the memory controller voltage. I'm not sure that this is not certain that this is actually optimal, but if we're just benchmarking, it does, well, depends how close to the edge of stability you are, but I did actually try lower, like, you can't raise this voltage any higher on Gigabyte motherboards, and lowering it doesn't help, not at memory speeds this high, at least with my CPU and this memory kit. Then VDD voltage is at 1.43, because the BIOS that I'm using on this board still has that bug where on certain memory sticks, if you try to set the VDD voltage above 1.43 volts, the board just doesn't post, because there's a issue with the way the motherboard tries to control the power management IC on the actual memory sticks, depending on what memory power management IC is on the memory sticks. So yeah, this is Like, the memory is not maxed out in terms of timings because the VDD voltage is actually rather low for, for a score that's like trying to be competitive on hardware bot, using 1.43 VDD is really low. Like, this is like daily voltages. This isn't bench voltages by any means. DDR VDDQ is at 1.35 volts because that just kind of works best at these kinds of memory speeds. Raising it hasn't given me any extra stability. Lowering it makes things worse. So, yeah. So that's the memory voltages there. For advanced voltages, VDD MISC is at 1.1, VDD-P is at 1 volt because at very high memory speeds, for some reason, really low VDD-P works best. This is like an auxiliary voltage for the memory controller that's generated from VDD-IO. As far as I know, VDD-IO is actually used to replace the old VDDR rail. So on DDR4, you had a power rail that powered the memory stick and the memory controller, and they would use that rail to talk to each other. Because DDR5 has its own power delivery on the memory stick, there needs to be a replacement for the old like VDDR rail, and that's what VDD-IO is. And the VDD-P is probably just powering like control logic in the memory controller rather than actual like signal, like signaling to the memory sticks. Though don't quote me on that. I don't design memory controllers, but that's like my gist of an understanding of how those work. For VDDG, I have 1.02 volts on the CCD voltage and 950 on the IO die voltage. This can help with the Infinity Fabric stability, but I've not really... I think this is basically the settings I used in some other memory overclock video with the CPU. So, yeah, I didn't really pay much attention to tuning these. These were just sort of like, well, I used these before and they worked fine, so I'm just going to use them again. And then these two being set to 1.82 volts, I think this is a leftover from some experiment that I forgot to, like, ditch. So you can just ignore those. Anyway, let's take a look at the memory settings. I have power down enabled because if I disable it, it causes, like, it actually doesn't make much of a difference to the performance, and it does cause issues with repeated reboots not properly booting, and then you have to like disable the memory context restore. And I didn't really feel like dealing with all of that, especially because I've been doing a lot of rebooting considering how often Ycruncher just straight up crashes. So didn't really feel like waiting for it to retrain the memory every time the system crashed. I also messed around with disabling gear down mode, and it can actually kind of run with gear down mode disabled, but I've not actually been able to get a better score than what I got with gear down mode turned on. So disabling gear down mode doesn't make enough of a difference in terms of performance for me. At least, like, the issue is, like, obviously the benchmark likes to crash. There's some run-to-run variants, so maybe if I had a cleaned up operating system, gear down mode off should be faster, assuming that I can get relatively similar clocks and timings, which it definitely affects the cast latency. You can't run it as low if you disable the gear down mode. But yeah, I haven't been like I've messed around with disabling gear down mode. Didn't really see any benefit in terms of the scores that I was able to achieve, so I just run it on auto. So yeah, even though very technically being like disabling gear down mode is faster, like it's supposed to be faster. The fact that I haven't been able to get better results without it probably is a skill issue. Anyway, let's take a look at the memory timings. So yeah, these timings are like not that different from what you would run these sticks daily, because my memory voltage, like the VDD voltage, is basically a daily voltage, right? We're at 1.43 volts VDD, so the timings, especially the primaries, can't really go that low. So 36 cast latency, because if I lower it, it doesn't work. And TRCD at 47, because if I lower it, it doesn't work. TRP at 45, because if I lower it, it doesn't work. TRAS at 38, because technically I think I could lower TRAS, but if you don't also lower TRC, that doesn't make a difference, really do anything to your performance. And I did try lowering the TRC, and I think 80 still works, but like 78 doesn't. So yeah. And I think at 80 it starts actually causing like stability problems, like more stability problems than this already has, right? Because this is on edge. um, as it is. So, yeah, like not much point. Like technically, the TRC could probably go a bit lower. Not much point in doing that because the performance doesn't really change if you change much if you lower TRC by 3 ticks, and the stability is getting steadily worse and worse. TWR is at 48. TREFI is completely maxed out. TRFC1's at 699. This could go lower. The thing is, it couldn't go much lower. It's not like you're going to drop it to 500 because this is 24 gigabit MDI, and 24 gigabit MDI does not do like I think 670 like still works, but 670 and 699 are kind of the same thing in terms of actual performance. Like if you do the math on how long your RAM spends refreshing with 699 versus 670, it's basically the same. Consequently, the benchmark doesn't really speed up significantly if you go from 699 to 670. So, yeah. Though at the same time, 670 shouldn't really negatively impact stability at all, but it also doesn't really change the performance. So it's kind of like, no point. This isn't like DDR4 where if you go from well, especially Ryzen DDR4, where you couldn't adjust the refresh interval. So going from like 200 and like from 300 TRFC to like 260 TRFC was a big deal because that's proportionally a much larger change. Or even going from 300 to 280 is a bigger deal than going from 699 to 670 with DDR5, especially because we can just max out the refresh interval. Though the auto TRFC, which is like 1600, yeah, that would actually be really slow. That's like auto TRFC is bad, but 20 ticks like going from 699 to like 670, not really much of a difference. Anyway, TRP's at 12. I did not check if less than that would actually work. TRP also doesn't tend to, RTP doesn't tend to make too much of a performance difference as it only affects pre-charge operations, which the memory controller can kind of hide pretty efficiently. So, yeah. Also, this really shouldn't... Oh, actually, you can set it really low on Ryzen. But, well, I don't think it would work at 5, so it's not really a concern. Anyway, TRRDL's at 10. I did not check if 8 would work. 24 gigabit MDI doesn't generally do super low TRRDL, but yeah, I didn't verify that. TRRDS is at 4. You actually just can't set it below that. TFall's at 20. You can't set it below that. TWTRL is at 20. I did not check if it would go lower. It probably won't go below like 16 though. But yeah, I haven't checked. WTRS is at 6. I didn't check if it would go lower. These two actually might be worth tuning because these affect your like write to read timings. And for something that's very bandwidth heavy like Ycruncher, being able to transition from write to read commands quickly can be kind of helpful. Being able, like, you're probably going to be transitioning between read and write, like you're going to be transitioning between like write and read operations a lot more often than say how often you have to pre-charge. So anyway, read to read SCL's at 7. I did not check if it would go lower. Actually, yeah, I didn't check if it would do 5, but I'm relatively certain it wouldn't. Now, here's a weird one. For some reason, you can set write to write same chip select to, same bank group to 1. Which makes me think that the Ryzen memory controller is actually, because you have to consider that the Infinity Fabric has, a speed limit on the write operations. It's probably not capable of queuing up enough write operations to actually use this timing, which is why you can set it to 1, is my theory, because on Intel memory controllers, this doesn't work. You shouldn't be able to have your long write-to-write delay, like your long write-to-write timing this low at DDR5 8000. Even with Hynix memory chips, which are really, really fast about back-to-back write operations, you shouldn't be able to set it to no delay. Yeah, that's interesting. It also didn't make a difference to the actual benchmark. I originally had it at 7, and then during tuning, I just, for fun, tried setting it to 1, and the score didn't improve, but it does work, so... But yeah, I don't think that timing is actually used by the memory controller because of that. Then we have right to read over here, which I kind of suspect this might only be used for multi-rank setups, because it doesn't make sense that we also have right to read over here. And then we have read to write, which is at 22. And I think I tried 20 and that wasn't stable. So, yeah. And if you're looking at these timings and thinking, these look very normal, yeah, that's because they kind of are. Oh, I also have all of the, like, termination and drive strengths locked in. But these are actually just the values that the motherboard trains on its own. So these aren't like some custom values that I came up with. This is what the memory controller will go, like, this is what the motherboard will use if you leave it on auto. And I just, like, set them manually so that it doesn't change them at random. Which it shouldn't do, but yeah. Also, if I wanted to adjust them, like, I know what the starting points are instead of, you know, having everything set to auto and having to go into Windows and check and then go back to the BIOS and change them from there. Anyway, and that's, I think, it. Yes. I mean, I think I disabled TSME over here, but I'm pretty sure it's actually disabled on auto, so... and TSME can improve your memory performance a bit. Like, disabling it improves your memory performance a bit. But that's also why I'm pretty sure the BIOS actually does it automatically for you. So yeah, that's the settings. It's actually just like slightly tighter 24 gigabit MDI timings compared to what you would run daily, because we're at basically daily voltages, right? Like that's, though it is clocked higher. And yeah, at this speed, this actually, like, it can run the Ycruncher benchmark, but this won't be passing stress tests at the memory speed that it's at right now. So, yeah, that's it. So if you have 24 gigabit MDI and a capable CPU and motherboard, you should actually be able to get a similar score to me. Or if you even have ADI, you should be able to get a similar score to me. In fact, ADI might be better for this, but I've not checked. So, yeah. Anyway, that's it for the video. So hopefully you found this somewhat interesting, if not particularly useful. And thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description. There's also the HOC Teespring store where you can pick up shirts, hoodies, posters, you know, the usual YouTuber merch. And I've also got a Bandcamp. There's a link to that down in the description below as well. And that's it for the video. So thank you for watching and goodbye.